Binary search. Sequential search is great, but how do you normally search for things? Let's say you're searching for a name in an old-fashioned, thick phone book. Would you use sequential search and start at the beginning, looking at each name in sequence until you find a match? Of course not. You would probably open the book to a page that you guess would be close to the name, see how close you got, and then go forward or backward until you found it. If you were off by a lot, you would skip more pages, and as you got closer, you would skip fewer pages. Eventually, you would find the right page. Imagine using this algorithm to find the page in a phone book that has a name you're looking for. If there is only one page in the book, jump right to step 6, the end. Step 2 is tear the book in half. Yes, that's right, rip it right in half. If the name you're looking for is in the first half, throw the second half away. If the name you're looking for is in the second half, throw the first half away. Then go back to step 1 and keep going until you find the page the name is on. This algorithm is pretty similar to the way we actually search for information. We don't usually tear books in half, and we don't always jump by exactly half of the remaining pages. Instead, we make educated guesses about how much to jump. Computers aren't good at educated guesses, but they are good at following directions. So in teaching our computer how to search this way, we'll use this rule of half. Because this algorithm keeps breaking lists into 2 pieces, this type of search is called binary search. We just said that binary search requires the things it's searching to be in order. How do we do that? Soon, we are going to learn some truly spectacular ways to sort lists, but for now, let's fake it. Let's create an array with already sorted numbers by just typing some in manually, like this. Let's talk about our strategy. We're not going to actually throw away half our array each time or copy half of it into a smaller array. Instead, we're going to simulate throwing half away by keeping track of the minimum, low, and maximum, high, indices. These will start off at 0 and array.length -1, and we will change them as we narrow down where our search term might be found. We will also need to know the midpoint, so we'll store the average of low and high in a new variable mid. Let's see how this will work. Here's our array with low, mid, and high, and a target of 15 all marked. The value on the previous slide of array mid was 27, which is greater than 15, so we know we need to look in the first half. We do that by setting high to the box that is mid -1. So mid was 27, so now high is going to be this box here, which holds a value of 22, which throws away the higher numbers, and then we recompute mid. So low is this first box, high is this box, mid will be the middle box between them, which holds a value of 8. Now, the mid value is 8 on the previous slide, and that's less than 15. So we bring low up to mid +1. So low was down here, this was mid. So now we're going to set low to this box here, which holds a value of 11. And now when we set mid to the average of low and high, we've found our target. So high is currently this box, low is this box, the box in the middle is our target of 15.